slope-intercept form. So up until now, we've really been focusing on the slope of a line, slope of a relationship. We're going to start to take a look at some equations that represent that same pattern, but if they move around on the graph. And we're going to represent them in slope-intercept form. So the y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis. It occurs when x equals 0. So if I look on my y-axis, my vertical axis, I'm going to see where this line crosses the y-axis. That's the y-intercept. If you think about interception, this is where the two cross each other. So there's my y-intercept, where it crosses the y-axis. We also can talk about an x-intercept of the line. This is where the x-coordinate of the point, where the line crosses the x-axis, and it's where y equals 0. So if I look at my horizontal line, it's where that graph crosses the x-axis. Again, if we think about an interception, if you're a football person, it's where here's my football, and then I intercept with my receiver. So we've got our two intercepts, one on the y-axis, one on the x-axis. Up until now, we've really been focusing on lines that cross at the origin, so it wasn't a very exciting intercept either way. Slope-intercept form is a linear equation written in the form of y equals mx plus b. We've seen this y equals mx before. This plus b is kind of new. We haven't seen that part yet. That is in slope-intercept form. The slope of the line is m. We've seen that before. That's nothing new. And the y-intercept is b. So that plus b at the end tells us where this line crosses the y-axis. So in that form, y equals the number times x plus a number. That number in front of the x is our slope. The number that we're adding on to the end is our y-intercept. Find the slope and y-intercept of the graph of the linear equation. So I have this equation, y equals 3x minus 7. It has to be in this form to take the slope and the y-intercept out of it. So it looks like y equals, that's a start, 3x, the number times my x. This is my rate of change. This is a rate. This is my slope. This is my constant of proportionality. This is how I'm changing that rate times x. It's the coefficient of x, the number stuck to the x. That's your slope. So in this equation, the slope is 3. And my y-intercept is that constant that we're adding here at the end. It doesn't have a variable stuck to it, so it's negative 7. So if I imagine this line on a graph, it would cross the y-axis at negative 7 below the origin. It would have a slope of 3. That's a positive slope. That's pretty steep. Second equation, y minus 1 equals negative 2/3 x. So this is not in slope-intercept form the way it is. So let's get the y by itself. I'm going to do that by adding 1 to both sides. So now my equation looks like y equals negative 2/3 x plus 1. So my slope, again, is the number that is stuck to the x, so negative 2/3. And my y-intercept is at 1. So if I picture what this graph looks like, it crosses the y-axis above the origin, very close to the origin, but above the origin. And it has a negative slope, so it's going down. And it's 2/3, which is not very steep. So we can pull those parts out of this type of an equation. All right, we're going to graph the line of each equation using the slope and the y-intercept. So here's my equation. Y equals, notice it's in y equals, so it's in slope-intercept form, equals 3 minus 2x. I'm going to rewrite this so it really looks like slope-intercept form. Y equals mx plus b. Remember, the m is our slope and the b is our y-intercept. My slope is negative 2. My y-intercept is 3. So here's my y-intercept up here at 3. I always start by graphing the y-intercept. And then I'm going to do my slope of 2. So I'm going to go down 2, rise of 2, run of 1. Rise of 2, run of 1. Rise of 2, run of 1. So I've got a negative line starting at that y-intercept at 3 on my line. I'm going to draw a nice long line, arrows on both ends. Let's graph negative 1/2 x plus y equals 1. Again, this is not slope-intercept form. I want to get the y by itself, so I'm going to add 1/2 x to both sides. So I have y equals 1/2 x plus 1. Y equals m. M is my slope, 1/2. X plus b. B is my y-intercept, so my y-intercept is 1. So I have a y-intercept of 1. I'm going to graph the y-intercept first. Then I'm going to graph a slope of 1/2. So rise of 1, run of 2. Rise of 1, run of 2. Rise of 1, run of 2. Draw a line through that. They should make a nice straight line when you do that. Arrows on both ends. So using an equation in slope-intercept form to graph that equation.